If you had the power to go back in time, would you fix a mistake, relive a perfect moment, or change one tiny decision just to see how different your life could be? Movies make it look easy. Movies make it look easy, but physics tells a very different story. Maybe to fix a mistake, relive a happy moment, or just to see what would happen if you did something differently. We've all seen it in movies. A hero zips back in a time machine, changes one tiny thing, and returns to a completely different present. But could this actually happen? Can we really change the past? Let's dive into what physics has to say about this mind-bending question. First, let's talk about the big guy in the room, Albert Einstein. His theories of relativity completely revolutionized how we understand space and time. Before Einstein, we thought of time as a universal clock, ticking away at the same rate for everyone, everywhere. But Einstein showed us that's not true. He introduced the concept of spacetime, a four-dimensional fabric where the three dimensions of space and the one dimension of time are woven together. Think of spacetime like a giant trampoline. Massive objects like planets and stars create dips or curves in this fabric. This curvature is what we experience as gravity. But here's the cool part. Not only does gravity affect space, it also affects time. This is called time dilation. The stronger the gravity or the faster you move through space, the slower time passes for you compared to someone in a weaker gravitational field or moving slower. This isn't just a theory, it's been proven. GPS satellites have to constantly adjust their clocks because time runs slightly faster for them up in orbit than for us down here on Earth. If they didn't, your GPS would be off by several miles every single day. So, we know time is relative. Does that mean we can travel through it? Well, traveling to the future is, in a way, possible. If you could hop on a spaceship that travels near the speed of light, you could go on a round trip for what feels like a year to you, and when you return to Earth, decades or even centuries could have passed. You would have effectively leaped into the future. But what about the past? This is where things get really tricky and where we run into some of the most famous paradoxes in physics. The most well-known is the grandfather paradox. Imagine you build a time machine, go back in time, and prevent your grandparents from ever meeting. If they never meet, one of your parents is never born, which means you were never born. But if you were never born, you couldn't have gone back in time to stop them from meeting in the first place. It's a classic loop of self-contradiction. It breaks the fundamental law of cause and effect, or causality, which is the bedrock of how we understand the universe. An effect can't happen before its cause. To get around this, physicists have come up with a few fascinating, though highly speculative, ideas. One is the Novikov self-consistency principle. Proposed by Russian physicist Igor Dmitrovich Novikov, this principle suggests that if you travel to the past, the laws of physics will conspire to prevent you from creating a paradox. Any action you take was already part of history. So if you went back to stop your grandparents from meeting, you would fail. Maybe you'd slip on a banana peel on your way, or your time machine would break down at the last second. In this view, the past is fixed and unchangeable. You can visit it, like watching a movie you're already in, but you can't alter the script. Another mind-bending idea comes from the world of quantum mechanics, the many worlds interpretation. This theory, proposed by Hugh Everett III, suggests that every time a quantum measurement is made, the universe splits into multiple parallel universes, one for each possible outcome. In this framework, if you travel back in time and change something, you don't actually change your own past. Instead, you create a new, separate timeline or branch of the universe. So, in one universe, your grandparents meet and you are born. In the new universe you just created by interfering, they don't, and a version of you will never exist there. You, the time traveler, would then be stuck in this alternate reality, unable to return to your original timeline. Your own past remains unchanged, but you've just become a visitor in a different history. This sounds like something straight out of science fiction, and in many ways it is. The many worlds theory solves the paradox problem, but it comes at the cost of an infinite number of parallel universes constantly branching off from one another. It's an elegant but extravagant solution. So, where does that leave us? Let's talk about the practical side of building a time machine. According to our current understanding of physics, traveling to the past would require some pretty exotic ingredients. One idea involves something called a wormhole, also known as an Einstein-Rosen bridge. A wormhole is a theoretical shortcut through spacetime connecting two distant points. If you could create a stable wormhole, you could potentially use it for time travel. You would take one end of the wormhole and accelerate it to near the speed of light, then bring it back. Due to time dilation, the moving end would have aged less than the stationary end. By stepping through the wormhole, you could travel from the older end to the younger end, effectively traveling into the past. However, there are huge problems. First, we've never actually observed a wormhole. Second, even if they exist, theory suggests they would be incredibly unstable, collapsing the instant anything tried to pass through. To keep a wormhole open, you'd need something called exotic matter, a hypothetical substance with negative mass or negative energy. We have no idea if such a thing can exist or how to create it. It would violate several known energy conditions in physics, making it a highly unlikely possibility. So, to recap, Einstein's relativity shows that time is not absolute and can be stretched and squeezed. This opens the door, theoretically, to future travel. Past travel, however, is a whole different beast. It's plagued by paradoxes like the grandfather paradox, which violate the fundamental principle of causality. Possible solutions, like the self-consistency principle, suggest the past is immutable, and you couldn't change it even if you tried. Alternatively, the many worlds interpretation suggests you could change the past, but only by creating a new parallel universe, leaving your original timeline untouched. And as for the how, building a time machine would likely require manipulating wormholes with undiscovered exotic matter, a feat that is far beyond our current technological and scientific grasp. It might even be fundamentally impossible. So, can the past be changed? Based on what we know right now, the answer is most likely no. Our universe seems to have very strict rules about cause and effect. While it's a fun and fascinating idea to explore in fiction, the physics of our reality seems to protect the timeline. The past, with all its triumphs and mistakes, is what made the present what it is. Perhaps instead of wishing to change what's already been written, the real power lies in what we do with the time we have right now in the present to shape the future. After all, today is yesterday's future. What will you do with it?